Have you ever wondered how modern applications handle millions of events every second? In today's video, we are diving into real-time event processing with three powerful tools: EventStream, EventHouse, and EventHub. We'll also explore how Microsoft Fabric makes data workflows seamless for faster real-time processing. And this video is a part of a free Data on Azure Masterclass where we guide you through a three-step framework to help you get certified and land a high-paying job. Over 45,000 people like Shrija, Mark, and Stephen have already benefited. So don't miss out this opportunity. Register through the link given in the description below.
Today, we have two goals to cover. We will look at real-time workloads inside the Fabric. What are the options that are available to us inside the Fabric for real-time incremental dataset processing? We will also look at today data warehouses, right? We'll get started with the traditional SQL data warehouses based on the traditional SQL Server engine, right? And data warehouses offer to us advanced capabilities which are not found in traditional lakehouses, right? Which we will see that how we can go ahead and we can proceed with warehouses as well. So without any further ado, let's get started with our real-time workloads in Fabric. I would now demonstrate a very beautiful scenario. I have data generating application. It's an application that generates or rather captures the data of vehicles speeding on the roads. So there are applications which will capture this data. So I have that application which captures the data of speeding vehicles on the roads. Our aim is in real time to capture all those vehicles that are speeding beyond a certain limit in real time. So if you cross that speed in real time, a threshold speed in real time, it will appear into our system and we can then go ahead and alert, or we can then go ahead and put it on dashboard. We could even do a tumbling window analysis where we could say that if you are speeding above a certain speed for the last 5 minutes, right? So we could say that if you have continuously broken that speed limit for 5 minutes, then we can identify you that you're speeding, right? Let's say you're driving on a highway and you are speeding, let's say at 100 plus. So if you speed at 100 plus for continuously 5 minutes, we get an alert, right? Your vehicle identification number appears to us that you are speeding, and all of this data is generated through GPS, right? So I have an application that captures that data. And that data obviously will be real time because you are driving your vehicle in real time. Now, the aims and the objectives are to get all those vehicles that are speeding beyond a certain threshold, and then obviously figure out also a tumbling window or a sliding window or a hopping window or a session window based analysis, timing analysis, right? So without any further ado, let's get started. So first of all, let me capture for you, let me show to you, first of all, the over here, right? So if you observe, just give me a second. So uh, transactions generator, right? Just a second. Oops, under downloads. So here it is, transaction generator, transaction, show all the folders that I have. Okay. Okay, so I'm gonna go here and open this one. Okay, let me do it here itself. So if you were to see that transaction, here it is. So I have an application, right, that can generate, here you see, transaction generator. Here you can see the transaction generator application. And here is the app settings file of the transaction generator. Now, what will this application do? right? It's a console application which collects the data of the vehicles speeding on the highways using GPS. Okay. And it is currently simulating the data of, I think, UK region. Okay. But look at it. We need to send it to a real time event ingestion system that can, excuse me, that can also collect it in a lake so that we can create its bronze copy in the lake. So I have two requirements for you, that you take the data from here. Let me just quickly open the whiteboard. Okay. Because that will help us to also continuously draw its diagram, what we are doing. Okay. So let me just grab a diagram. Okay. Here we go. So whiteboard. Okay. Let's continue. So we are implementing streaming in Fabric. So streaming in Fabric. Okay. So the scenario is pretty simple, that I have over here an application. I have an application which is a transaction generator application. Transaction generator. Transaction here means an insert, which means it is recording the data of the vehicles using GPS, right? So it is recording the data of the vehicles using the GPS. Okay. And obviously it will now produce a real-time stream. So what comes out of this is a real-time stream. Real-time stream. So a stream comes out of this because it will continuously emit the data of the vehicles that I have configured it to monitor of a particular latitude, longitude. Now, this has to be ingested using some real-time ingestion technology, which can also collect this data as a batch, right? So it should also allow me to create the bronze collection, right? Original files, as you know, bronze collection. So it should allow me that this incoming data that is coming as a stream, right? It is coming as a stream. Let the stream go ahead, but I also want the stream to be collected over here. That would make it a bronze collection, so that later if I want to use this data, I can use it for various other batch processes, right? So if I want to use it for machine learning, data science, or any other form of analytics, I can use it. Okay. So this will be nothing but a data lake, right? So we're going to be using ADLS Gen 2. And then the data of this ADLS Gen 2 will be written into the Fabric bronze delta, right? So this you can write into the Fabric. How you can do it, you know it by now, that if the source is this ADLS Gen 2, I have two ways. I can either move this data or I can simply put a shortcut, right? So you have two options, that you can put a shortcut or you can do it via the pipeline, data ingestion pipeline, copy pipeline, or data flow Gen 2. So you can do it via the copy or Gen 2. Those two options are open. That's up to you. Okay. So it can go to the Fabric Lakehouse Delta, okay, in the Delta table, right? So that is fine. Okay. This will be the bronze collection. So what will be this event ingestion software? Event ingestion event ingestion service that can help do this, which means not only collect this data and send it to the consumers, not only select the data, not only select, not only get this data and send it ahead as a stream, but also collect it as a batch, bronze batch over here, also collect it as a bronze batch over here, and then let me connect it to the tables in the warehouse. No, this will be a separate lake, not one lake. Let's not confuse. This is not Fabric, not one lake. This is a separate ADLS Gen 2, which I'm using for collecting because this at the moment does not support collecting in the one lake directly. You collect it in a separate ADLS Gen 2 and place a shortcut in the fabric if you don't want to copy this data, or move it via the pipeline if you want to copy the data in the Delta. Okay. So what is this service? So this service is Event Hubs. Azure Event Hubs. So we need to first deploy the Event Hubs. So let's quickly do that, right? So we will deploy two things. We will deploy the Event Hubs, and we will deploy this ADLS Gen 2 for bronze collection. This is not one lake. You need to place a shortcut of it in the fabric, and that's how fabric will maintain the metadata of it in one lake. Okay, fabric will maintain the metadata of it in one lake because data will remain over here. Or if you want to copy the data also, you can do it via the pipelines. That's up to us whether we want to do it or not. So we will quickly deploy these two products. So here you can see that, and we will create two things, event hubs and a lake. Let's first do the lake. So I say storage account, storage accounts, and here comes the lake for bronze data collection of the real-time stream, whose shortcut I can then place in my fabric. Not a big worry, right? We can do this. So MCD subscription, put it inside a resource group. Let us say solutions, streaming solutions. Okay. Okay, give it a name, bronze vehicle data, bronze vehicle data. So it is a bronze vehicle data that I have over here, right? I can say that created in Central India, primary services blobs. I want standard performance with LRS configuration, and it should be a lake so we can enable namespaces in it, hierarchical namespaces, review and create a simple lake. Okay. We will require this for what? Collection of the vehicle data. So all that vehicle data that is coming as a stream, I want to collect it so that I can do batch on it later if I want to do batch. Okay. So this is the best practice, that always maintain the data of the streaming source as a batch for any other batch process like machine learning, data science, okay, reporting. Okay. So here we can see bronze vehicle data getting created. Meanwhile, it is getting created, we can deploy another service, which is that an ingestion service. We can keep the data in the lakehouse, but this ingestion technology does not support directly in the fabric at the moment. Maybe Microsoft will bring that option that you directly collect it in the fabric lakehouse. But currently, let's continue the demo. You will see it for yourself, right? So I go to Event Hub, and now I will deploy the Event Hub for you. Currently, this tool, which is Event Hubs, it does not support that you can directly put it here. Can you understand? It says you cannot directly put it here. It says you first put it here, then place its shortcut here. Okay. Maybe in the future, this feature will come that you can directly put it in the fabric. There is no need for you to first put it here and then put it in the fabric. Currently, it says I will not allow you to do that. I will allow you to first collect here, then go here. Okay. I hope you can understand. So let me now deploy. Meanwhile, you see our lake is deployed. The bronze vehicle data, hierarchical namespace enabled, hence it is a lake. Okay. So I'm going to create a folder within it or a namespace within it, container, and the name of the container is bronze bronze vehicles. Okay, bronze vehicles. So vehicle data in the bronze layer, create. So it is in this folder that everything will get collected as a bronze copy of what is getting streamed, so that this data can be used for batch processes. Okay. We can use it for machine learning, data science, or whatever. Okay. So here it is. So I go over here. Let's deploy our event ingestion service, this service, Event Hubs. Okay. So let's go ahead. I say put it inside my streaming solutions, give it a name. Let's say give it a name, vehicle ingestion namespace. Okay. Ingest namespace. Okay. In Central India, we are sufficient with standard. This is the throughput unit. How much data can it ingest and how much data it can throw out. So the rate of ingestion and the rate of throwing it out, right? So I can say I want 10 throughput units, and if in case they are not sufficient, auto inflate them to 20. That would be sufficient for the demonstration, right? Next, no need to change anything. Next, no need to change anything. No need to change anything. And that is it, the namespace of hubs. A namespace is created before creating a hub, so that if you want to keep all the hubs of a single project together. So a namespace helps us to keep the hubs of single project together. Okay. It's a DNS. So here we go. Vehicle ingest namespace, and now inside this namespace we can create thousands of hubs for different purposes, but we only have a single hub requirement here, that we want to take the data of the GPS vehicles. Okay, so let it be created. So the data from the original source, which is my transaction generation application, which will be real time, will be streamed by this in real time, and also collected by it over here for any kind of a batch process. Okay, so here we see this is our event hub. Currently we don't have any event hub. This is our event hub namespace, so let's create just single hub inside it. So I say give me a hub, and I say this is my vehicle GPS data. Okay, vehicle telemetry, I can say vehicle telemetry, vehicle telemetry. Okay, we can even partition it if we want for concurrent consumers. I will only create a single consumer for it in Fabric, a single event stream for it in Fabric. If in Fabric you create multiple event streams on this source, it would be better to keep equal to that. So in the Fabric, if you observe, we have an option which says go to real time and create, go to the data sources and go to Microsoft sources, and you can see here there should be event. Yeah, here it is, Azure Event Hubs. So if you connect to this source, how many unique event streams you are creating? Connect to the same source. Source can be same, but if you create multiple streams over here, equal to the number of streams, because this stream is nothing but the consumer. Okay, it goes into the consumer. You can see that it goes into the consumer. Okay, so partition count should always be equal to the number of concurrent consumers, that is equal to the number of concurrent event streams that you can create on this source in your Fabric. If you want to create 5 event streams on the same source, there should be 5 partitions that we should create, equal to the number of concurrent consumers, maximum up to 32, right? We will only do one, right? But in a real world, you are doing one thing with the same data and you have another logic on the same data and you are creating 2 separate event streams. You can do it, right? No problem. So partition count, don't need to change anything. Cleanup policy or retention. Retention can be up to maximum 7 days. But look at this beautiful option, capture. What does that mean? All the incoming real-time data to this hub can be collected into a storage account. That is our bronze vehicle data in the bronze vehicles folder in a small batches of 2 minutes, because it's a batch, right? I don't want to write 1,000 files every 1 minute. I want to write every 2 minutes or every 300 megabytes, whichever is smaller, whichever is earlier. So if you get data which is 300 megabytes, please write it into that folder. Or if you don't get 300 megabyte but you expire 2 minutes, write whatever you have in 2 minutes, let's say 50 megabytes. So whichever is earlier. And you see it will maintain it to such a granularity up to the level of seconds. It will maintain it up to the second. Which data came at what second, it will maintain that information. This will maintain it in original format, JSON format, because our data will come in JSON format. Can you do it in Parquet format? Can you do it in Delta format? Absolutely yes. If you want to collect this data not in the original form, my transaction generator application will generate it in JavaScript object notation. The original form is JSON. Do you want to collect it in JSON, or do you want to collect it in Parquet, or do you want to collect it in Delta? Even Delta is supported. If I on it here, it will collect it in JSON format, the original format. But if you want to collect it in Parquet and Delta, that option is also there. We will discuss it afterwards. But I am configuring this at the moment, that collect it in the original shape, original form. Okay, whatever the original data that is coming from the source. Okay, which means from transaction generator application, to collect as it is. Okay, so storage, bronze vehicles, and up to a level of second. Amazing granularity, right? So this is sufficient for me. I say review and create my hub. Name of the hub, single concurrent consumer, which means I will only create a single event stream on it in my fabric. Cleanup, delete or retain, deletion period up to 7 days is possible. This we generally don't use. We use capture, right? So this is fine. I can say, please create it for me. Here we go. In the capture, I told it that capture it in the Avro format, binary JSON, right? I have the option to collect it in Parquet and Delta, but that would be slightly complex. Let's not do that at the moment, but you can collect it in Parquet and the Delta format also. When you try it in Parquet format or try it in Delta Lake format, but I'm going with Avro only. So I say binary JSON on, write it in a windows of 2 minutes or 300 megabyte, whichever is earlier. Because I don't want you to write 1111 file containing 111 row and millions of files I have to give to the data scientist, right? I will have to then run file compaction unnecessarily, right? So generally we keep it 5 minutes generally, but since this is a demo, that's why I'm making it a smaller one, right? So it will get collected. So this part is this thing, this capture thing, not this thing, this capture thing, right? So I hope now it is clear. Okay, now we can proceed. So my event hub is ready. Okay, here is my event hub namespace and here is my event hub. Let us now create the source of the data. So let's go to the app settings file of the transaction generator application. The app settings.json file of my transaction generator application, which collects the data of the GPS of the vehicles, tells me I will give you the data. Where do you want it? I say give me in the event hub. So here I have to put the connection string of the event hub. But what kind of a connection string? Read or write? Right, because you want to send the data to the hub, which means you want to give it to the hub, not take from the hub. You are not taking from the hub, you are giving it to the hub. So my transaction generator application will give its data to the hub. That is means it will be writing in the hub. It will be publishing in the hub, not taking from the hub, publishing into the hub. So I need to go, you can see shared access policy. Go over here and in the vehicle, in the hub, vehicle telemetry hub. So go inside the hub. Where do you want to send the data? Inside the hub. Okay. And now shared access policy, add a shared access policy for send, that I want to send the data. I want to publish the data. I don't want to take the data. I want to send. My transaction generator application wants to send the data. So I say send. They will now give me a connection string to send. So I will take it. I will say, yes, I want to send. Okay. So send, and I will now copy this connection string. You see, they're going to give me this connection string. So I will take this and I will give it to my real-time application that please send the data to that event hub, which I want you to do. Please send it to the event hub. Okay, please send it to the event hub and I will run it indefinitely for you 18,000 seconds. right? Which will be roughly around 180 minutes, right? No, 60 seconds. So if you divide by 60, it would be, I think, 300, right? So 300 minutes. I will run it for 300 minutes for you. Okay. Save this file. Saved successfully. So my transaction generator app, which is recording the data of the vehicles in real time, their speed, their temperature, the engine oil and whatnot in real time, it will send it to the hub in real time. Okay. Close. Start the app. So I will now start the application. You see, transaction generator app. App has started. It is sending in real time. Here it will update for every 500 records. Here in the console, it will only print every 500, but it is sending it in real time. It is just generating statistics. Don't believe that it is sending a batch. It is telling us that it was doing 86 rows every second and it is generating the statistics. What does that mean? Data is now going to, so the source has been activated. This is now collecting the vehicle's data real time, also sending in real time approximately 86 vehicles, 94 vehicles, 95 vehicles every second, 93 vehicles every second, giving me the statistics. So where is that data going? Is data is going to the hubs, but is it going ahead? No, not at the moment. We have not connected anything. Right? Is it going ahead? No, nothing here at the moment. So where is it going? It is getting collected here. It is getting collected here because you see, we only configured this part yet. So now if I observe for you, if I show you that, if you observe, go to the overview section, you find that it will tell you that the data is incoming, right? But the throughput is 0, right? You'll see these will stabilize very shortly. We'll see the graphs again, but the data is coming. So can I know what data is coming? Yes, but how? It's not going ahead at all because we did not configure anything yet. But we said collect it as a batch over here. So is it working? Let's test it out. How to test it? Whether the batch collection is working or not. Whether the bronze collection of the stream is working or not. How to know that the bronze collection of the stream is working or not? Just check the folder, right? Go to here, see vehicle ingest namespace, vehicle telemetry event hub, partition number 0 because I only tell single partition has to be created, partition, year 2025, month 2nd, date 16th of February, hour 14, minute 29, 31, 33, 35, every 2 minutes. I told it, I want you to write every 2 minutes. It is writing every 2 minutes. You'll see 43 very shortly. You'll find 43 very shortly, right? So you see here that it is collecting the data in the binary JavaScript object notation format, Avro format. I can collect it for you in Parquet. I can collect it for you in Delta also, right? So when you practice, you collect it in Delta. I will show you how to do that. Very simple configuration, no rocket science, right? But here we can see bronze collection is 100% working fine. Bronze collection is 100%, 43. After few minutes, after 2 minutes, 45. After another 2 minutes, 47. So what is this? This is the bronze collection. I can now place its shortcut. If I don't want to copy this data, right? If I don't want to copy this data, I can place its shortcut in the fabric, lake house. So I can go, let's create a new workspace. Let's give it a workspace, new workspace, the class 6th, okay, workspace, apply. And that's where the concept of a shortcut comes, right? You don't need to create its duplication. Why to create its duplication? And one question came, why can't I directly collect in the batch? It did not give me that option. EventHub said you can collect it in a storage account or a data lake Gen 1 in either Parquet, Delta, or Avro format, but not in Fabric. Directly, it's not giving that option. Maybe few years from now, a few months from now, Microsoft may introduce that option that directly you can write to the lake house using the fabric, using the event hub directly. Okay, as a batch, as a batch. That option is there in the fabric, not here, right? So you see 47, 45 after few minutes, 47. Okay. So what to do? You can place it shortcut. So here, let's create a lake house. I say, please give me one lake house. And I say lake house. I can say vehicle lake house, LKH, lake house schema on, create. And if I go to the lake house in the lake house explorer, under the files, I can create a shortcut to it. Under the files, I can say I want to create a shortcut, and my shortcut is to an Azure data lake. I want to create a new connection. Okay. Any data source through this shortcut will be processed in the same region. No problem. Right. So URL connection string DFS, HDFS, DFS core.windows.net up till the file system. So I can grab it from here for you. So you see, if I go back a little bit, and if I go to the bronze vehicle, if I go to its settings, I go to its properties of the bronze vehicles, you find it here. It is in blob, so I will just say it in DFS. Okay. Distributed file system, DFS, distributed file system, name of the folder bronze vehicle, bronze vehicles, which contains all of that beautiful data. Okay. Create a new connection. That's it. Bronze vehicle data.dfs.co.windows.net. Name of the folder bronze vehicles. How do you authenticate? Do you have access? I will say I have the key of the account. So I can now punch the key of the account. So I go over here and I just check whether the key is enabled or not. First of all, under the configuration. So I go to the settings under the configuration. Let's see whether the key is enabled or not. Key is enabled. Okay. So key is enabled, so I can capture the key. Show the key, copy the key. And here you see, I put it as a key and I say next. Invalid credential. https://dfs core windows.net. Bronze vehicles. Connection name. Okay. Connection name. Account key is what I will give you. Did it copy the right account key? Show, copy, 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 copy. Okay. Paste. Next. Work this time, right? Don't know. Previously, it may not have copied it. Here we have all the data. Select it. Select it. What do you want to mount? I want to mount the vehicle telemetry of the 0th partition of the year 20. What do you want as a shortcut? I only want the year 2025. Everything below that. Okay. Everything below that. But let me take all of it for you, right? So I can take the entire hierarchy for you. Okay. This is the beauty of HNS, that you can take the data of the 16th Feb. See all you can take. I will say, I think we'll have to select the top level object only. So it will select everything. I say next, shortcut of it, create. So I don't need to copy this data. That's the meaning of shortcut. I don't want to copy this data. Why would I do such data duplication unnecessarily? Right? So I just told it I want to collect this bronze vehicles, everything under the bronze vehicles, 16 Feb, 17 Feb, 18 Feb, 19 Feb, all the days, right? It's collecting 16th Feb today. If I just leave it to run indefinitely, it will collect 17th Feb tomorrow, then 18th Feb. I hope you can understand, right? So we'll keep on collecting it. See, it is collecting continuously the data. Last collection was on this. It will keep on collecting it, right? If this keeps on sending, it will keep on collecting. But this bronze collection, I will now place a shortcut to it in here, Fabric Lake House. So you can, yeah, it will have some performance impact. Yes, you are right. Because these shortcuts are data virtualization shortcuts, right? These shortcuts are data virtualization shortcuts. They are not having the data in them. So they have virtualization, right? They are data virtual objects, right? So obviously, in order to read this data, it has to go to that storage account whenever you read it from here. So there will be some performance impact. But what I'm trying to show you is bronze collection of the real-time stream, which is a very popular interview question, which we will do 1,000 times in real projects, because the data scientists, the machine learning engineers, the AI professionals, they can ask this real-time data as a batch. So they could tell you, I want the last quarter data, which you collected here. Why? I want to retrain my bot with this data. I want to do something which is predictive analytics with this data. So that's where this data has to be used by us, right? So it will keep on collecting. It's an indefinite process. I hope you can understand. Until this guy is producing the data, until this person is producing the data, you see, it's continuously producing in real time the data, 95 writes per second. So until it keeps on producing the data, my event ingestion system will keep on ingesting it. See, now it is stabilizing. Okay. So it will keep on collecting the data in the bronze layer. And because it is collecting it in bronze layer, see 47, 49, it will keep on collecting it in the bronze layer. And I have placed a shortcut to it over here. So obviously, if I were to refresh them, see, they are appearing over here, right? That has to appear, right? Because this is data virtual object. It's just a virtual object. Okay. Whatever you see over here, it will reflect over there. If I get 51 over here, that will reflect over there after a few minutes. 51 should reflect over here because it's a data virtual object. Should reflect over here as well. 51 data virtual object. Okay, whatever is there will appear here, so there is no problem at all. So I just completed this part. Now after this, you know what we have to do. You are the king of what you need to do after Lakehouse. Load it to delta table, do queries on it, do visualizations, do explorations, load it to the Spark cluster, load it to your Spark cluster, do data frames on it, do delta lake on it, right? Do medallion architecture on it. Up to you what you want to do. I have nothing. I just provided you in your lake house. Rest is yours. And it is appearing in real time, isn't it? So as more and more data is generated by this person, my event ingestion system will keep on collecting it. Where? Over here in the bronze. So 51. After a few minutes, you'll see 53. And that will appear in your lake house over here. Yes or no? Right? So this is the bronze collection of a real-time stream, which is very important. What do you wish to do here? What I wish to do here is I want to do real-time dashboards. I want to do real-time alerts. I want to do real-time data processing using Custo query language. Right now, the data is of vehicles. What if the logs are coming in real time? I would have to process the logs in real time. So this is where Fabric allows us to process it directly, right? So now we hook up Fabric to it directly. So what do we need to do in the Fabric, right? So we now go to the Fabric and I now will proceed to the Fabric. So what do I need to do in the Fabric? Simple stuff. You need to create what's called as an event stream in Fabric to this source, which means you will have to, this guy was sending the data here, my transaction application, you need to read it. Hence, you will become a consumer. You will become a consumer because you will read it. So I want to read it in real time. And that reading is done in an event stream. We can create n number of event streams, which means n number of consumers. But remember, we said that we only want a single partition here when we created EventHub. So it would be better to create just a single event stream, right? Otherwise, the performance will drop significantly. So because I had told that I want a single partition over here, partition one, then I would also create just a single event stream over here, which is event stream number one for that partition, right? Otherwise, you should increase the partitions here equal to the number of concurrent event streams that you want. So the source will be this. This will be the source, and connecting to the source, we have to then create event stream. You can create as many as you wish, as I just told you. But in this case, because I told one partition in my hub, I will create just a single event stream. Because please remember that if you create, let us say over here, 4 event stream to the same source, there are 4 consumers to the same source. That means you need 4 partitions here as well. Otherwise, your performance will drop significantly. Okay. So make sure that the number of partitions in the event hub is equal to the number of concurrent streams created on the same source. Parallel consumers. Okay. So let's do that. So we need to just create an event stream. And event stream will allow us to do n number of transformations in real time on this data as the data is flowing, right? We'll never store it somewhere. Okay, don't store it anywhere. There is no need for you to store it. If you bring it to rest, it becomes batch. So you will not store it. We will not store it. N number of transformations in real time. This will allow us to do. And then finally, you have to make your output somewhere, durable output. If you want to send the output without storing the output anywhere, you have to send it to a Power BI dashboard. PBI dashboard, or also called as a real time dashboard. Will the real time dashboard store this output? No. As soon as you refresh your dashboard, the output will be lost. The past output will be lost. Do you want that to happen? Do you want your output to be lost just because you refresh the Power BI dashboard or your real time dashboard? No, right? I want it to also remain durable. So the output that is generated here after my n number of transformations, I will have two options. One, to take it to a real time dashboard. The problem of that would be the real time dashboard will draw the graph for me in real time. But as soon as I refresh that, or it will auto refresh itself, past data will be lost, right? But I can write it to another beautiful product to store the output. So output O of my n number of transformations which I did on the real time data, the final output of that, I can put it in an event house. I can put it in an event house. I can put that in the event house. And what does an event house contains? It contains KQL, Custo, query, language, databases, and these databases can collect the data of your output, the output in separate tables, and these tables now you can use on your reports, right? These are the KQL tables, and these KQL tables now you can use on your reports, right? And configure auto refresh in this report every 1 minute, or continuous auto refresh is also supported, continuous. So if you directly take it to the real time dashboard, past data can be lost because dashboard is not storing anything. So the better way would be to put it in the event house. Event house contains a KQL database, Custo query language database, which will contain a table and a query set. Okay. And using that tables and a query set, QS, and using that table, I can put it on a report and continuous auto refresh. So whatever the output is coming, that is getting reflected on my real time dashboard. The recommended architecture is to keep it in the event house in the KQL
Okay.
database. The reason for that is this is real time reporting that we are doing. I will write it to a data warehouse if the report is not required to be refreshed so frequently. So let us imagine
Okay.
you are a CEO of an organization, or let us say you are a product manager or a sales manager. Do you want me to report to you the total sales every day, every 1 hour, every 1 minute, or continuously? What do you want? Generally, what happens is that we do not typically want reports to be given so frequently. If I want to know something meaningful about my product sales, wouldn't I say at least give me 7 days of data to see what is happening? Will I just take the data of 1 minute and tell you that this product is bad and this product is good? No, right?
Right.
So if I am the sales manager, I would want you to give me and furnish a report of my sales of the products every 7 days, or every quarter sometimes, or every 1 day, but generally not every hour or every minute, right? I cannot understand, that does not give me any meaning. How can I just look at a sales of a product in 1 minute and say that this is not selling, this is a poor, and this is very good, this is selling? No, you have to at least see maybe 1 day of data, maybe even 7 days, or sometimes we see quarterly data to see, oh, this product line is failing. This I think is a failed product. This is selling. So this is a good product. Let's focus on this. So real time dashboarding generally is not required for financial KPIs. Here I am just tracking which person is over speeding. I need to immediately. I cannot wait for 7 days that this person was over. That's why I'm writing it to EventHouse. If the requirement was that you need to you need to report it in 7 days, or report it every quarter, or report at least 1 day, I would not write to EventHouse. I would write to a warehouse. That's our next topic. That's why that thanks for bringing it here, right? To let people understand that here we are writing it to EventHouse because the report refresh granularity is of the orders of minutes. Someone is telling me, I want a very quick report, right? I want quick numbers to happen in front of me. Why? Granularity is of the minutes. Time granularity is that of the minutes. Why? Well, I want to know immediately which vehicle is overspeeding. You need to report to me every 5 minutes. If the vehicle appears continuously overspeeding in 5 minute window, I have the vehicle identification number. I can generate an alert that goes to the app of that individual that, hey, you are found to be overspeeding. Or I can just give him a some kind of a ticket, say that you have a fine of $20, you're overspeeding. We recorded it. Okay. Because the granularity here is of minutes, requirement is that we are writing to EventHouse, but there is purely an option, no problem at all. You can write it to the warehouse as well. If the report granularity is higher, maybe 7 days, 1 day, 1 quarter, 1 month, right? Then we will write it to warehouse. Otherwise, we'll write it to EventHouse. So let's implement this part quickly. Meanwhile, let me just show you that our batch part is totally working fine. So here is a real-time streaming application which is generating 87 writes per second. Okay, it's continuously sending 93 writes per second. It will continuously run for 180 minutes. Okay, it is keep on running for 3 hours, which means, okay, so it will keep on running, sending the data. Where is it going? It is going to my event ingestion system, event hubs. But I have not connected anything to this hub over here, nothing here, only here. So it is collecting it in bronze at the moment. Bronze batch collection is taking place. So if you observe at the moment, all of this data that is coming in is going to the capture system. Bronze data collection is taking place up to the minute, up to the granularity of a second every 2 minutes. So if we go here, you find 55. Now lot of folders would have popped up. 59, right? Lot of folders would have popped up. It is writing continuously. See whether it did not create another partition. 2025 to 16, it created 14th, 16th February, 14th hour, 15th hour, hour changed, new hour kicked in, right? 15th hour, 1 minute, 15th hour, 13th minute, 15th hour, 5 minute, 15th hour, 7th minute, 15th hour, 9th minute, every 2 minutes, every hour, every day, every month, every year. It will continuously record it, right? Continuously until this source is running real time. Okay. Up till now is the batch part of it. And we connected to the lake house in the fabric. You can see this should reflect now everything that you want. Okay. So 14, now 15 should appear. 16th Feb 2025, hour 14, hour 15. Hour 15 here, because here hour 14, 59th minute was already completed. We don't have more than 60 minutes in an hour. So 59th minute, 15th hour, first minute, 15th hour, third minute. It's collecting. What is this called? A time series. Technically, we call this as a time series. So it is collecting the time series for you. It's collecting the entire time series as a shortcut. We are not copying this data here. Whatever is here, let it remain here. Virtualize it over here. This is called a data virtualization because it is a shortcut. Okay. Up till here, we completed this part of the architecture. Now we complete this part of the architecture. This is called as a real-time layer, and this is called as a batch layer. This is also called as the cold layer, and this is also called as the hot layer. So some people call this as a hot layer. This is hot or real time or streaming. And this is whatever is happening here is cold, is batch, not real time. It's a batch. Right? Machine learning, data science, blah blah blah. Whatever you want to do. You have your data in a Fabric Lakehouse now. Okay. We know what to do. By now, I hope you are able to understand. Once you give me the data in the lake house, I am the champion. I can do whatever I want with it. Okay. Let's now do this part quickly. So I go over here to the fabric, right? Let's go back to the home page of our workspace. And what do we need to create? You need to create an event stream, right? So let's go and say I want an event stream, new item. And what I want is an event stream. You see, store data, prepare data, analyze and train, track data, visualize data, develop data, others. So where is that? Get data, event stream. Give your event stream a name. This is a consumer. This is one of the consumer, right? So let me give it a name, vehicle data consumer, vehicle data, or we can say vehicle event stream. You know it is a consumer, right? It wants to read, right, from that event hub. It wants to read from there. So I give it a name, vehicle event stream. It wants to read from here. It wants to read from here. So it will ask permissions just the way we gave the permissions here. We have to give the permissions over here. So I go over here and you see over here, there is an option to go back to the shared access policy. Send permissions were given. This time we will require read permissions. Read. That is listen. Who will require this? Our event stream. It wants to listen. It wants to read. It wants to get the data from this hub, right? My transaction application wants to write, wants to send, right? But the event stream wants to listen, wants to read. So let's do that. Read. This is what we will need. Okay. So let's go here. So now add the source. Where is your source? Okay. So I say my source is an external source. And that external source is a hub in Azure. I say, okay, connect. It says, please give me your connection to it. I say, I want to create a new connection. I want to create a new connection. It says, give me the name of the namespace inside which your hub is. Okay, so where is that name? Here is the name of the namespace, NS. Copy that. It wants it, give it. Second, what does it want? Name of the event hub. Copy. Give it. Create a new connection, it takes that. Now, how would you prove that you have read permissions? I say I have a shared access key. Give us the name of that key and the key itself. So I go over here. What is the name of the key? Read. That's what the name we have given. Read. So read. Read. What is the key? Now I need to copy that. So I will copy this key, primary key. Copy, 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 copy. Okay. Many times because it sometimes does not copy in once. Verified is copying. OE. OE. Yes, it is copying. Ready? Test the connection and connect. Connect me to my source event hub because I have the read permission. It says thank you, I'm able to do it. Because you will be the consumer, it says in which group of consumers do you want to get added. See, we can create consumer groups over here if you observe, right? So if I see consumer groups, who are consumer groups? If you want to process the data that is coming here in parallel, you will create consumer groups. It's a complex architecture, right? When you go to the pizza, let's say you go to Domino's, there are so many people who want to order a pizza. So what we find over there is at least three or four different counters where you can go and you can talk with the sales boy or the pizza boy over there and ask him to take your order. Do they have a single person taking it? A single server? No, multiple of them. Why? Because the number of customers coming is way more during the lunch time. So they want to process that incoming stream of customers in parallel, right? So four counters are there. You go to any of the counter, there is a queue in and queue in front of every counter. You just get your order punched. We have four different pizza boys recording your orders. Parallel, concurrent, consumers, off, the customers stream. Customers are appearing in real time, right? You are coming in real time over there. It's not that the batch is coming. Every 5 minutes, 10 people will come to that. No, people are coming randomly in real time. So that's the concept, that you can create a consumer group over here and let multiple event streams process it in parallel. But we don't need that at the moment. I don't want to overcomplicate the issue. But yes, from data engineering perspective, it can be done the way we do it in real world, right? If the data is coming in large volumes, I would prefer to process it in parallel, hence have multiple partitions of the hub, have multiple event streams of the same source, and have multiple, have a consumer group in which I can put them. Okay, we can put maximum five consumers in one group. Okay, just like five different counters on which you can go and get your pizza order booked. Okay. So I am putting it in default and data format, incoming data format is JSON because my event hub is throwing JSON data. That's it, ready. Next, add. And here it is added on the beautiful canvas. And we are in the edit mode of the canvas. Let us just see what real-time data is coming. It is giving us a quick preview. And here is the data that is coming from the source. So this is coming from here in real time. This data is coming from here in real time. Wonderful. A lot of data is there. We can do very complex analysis with it. I don't want to overcomplicate the issue. We can understand the speed for a particular vehicle. We can understand the fuel that it has, engine oil, tire pressure, odometer reading that they have, engine temperature, outside temperature, city, region, whatever. All of this beautiful data that is coming where a particular person is driving. But and timestamp is also there. Okay. So we can do very complicated time series data processing of it. But in the demo, I want to keep it simple, otherwise, it can become very complex to digest. I simply say, give me such vehicles that are over speeding beyond a certain speed limit. So just filter the vehicles on the basis of the speed. So here you see, now I can add thousands of transformations on this in real time. I'm not storing the data anywhere. Please believe me, right? It's flowing, okay? We never stored it anywhere. It's flowing as a stream. So I say do this on stream: aggregation, expand, filter, group by, join, manage fields, union. And these are the destinations. See, Lakehouse is the destination and Event House is the destination. They are not giving us the option to have a warehouse as the warehouse as the destination. You have to first put it to the Lakehouse and then run a pipeline to take it from Lakehouse to the warehouse. You cannot directly take it to the warehouse. Why? No one does it. Warehouse is made for reporting that is of the nature of every day, every 7 day, every quarter. It's not made for reporting of the nature every minute, every 5 seconds, every 100 seconds. No, no, it's not made for that purpose, right? So what will I do? I say I want to filter. Say filter setup required. What do you want to filter? I say speed limit crossed. Speed limit crossed. Speed greater than value 90. If you go above the 90 speed, we immediately catch your vehicle number, punch you a ticket. Real time, it will appear to you that you have a ticket of $20 of fine. You are overspeeding. Or we could say you are overspeeding continuously for 5 minutes above 90. It's a deliberate thing that you are doing, right? That you're overspeeding beyond 90 continuously for 5 minutes. So then I will have to do a window analysis on the timestamp, right? That is a separate part. I have another notebook for window analysis. Let's keep it this simple. Greater than 90, I say save. Says error. Why? You need to add output first. Then it will give you. So I say I can do 1,000 more transformations for you. I have an exercise in which we will do time series analysis of this. That every 5 minutes give me the report for every vehicle. right? That I want every 5 minutes the report of every vehicle. What is the average speed in that 5 minute? If it is more than 90, I punch you a ticket in real time. Or I send you an alert in real time in your app that, sir, it seems you're overspeeding. Next time you find overspeeding a fine, if you are a good driver, you will come back to the normal range, which is maybe 70, 80, according to the highway zone. If they allow above 90, fine, but not so, it will give you an alert in real time, right? One, if you skip two alerts, the third alert will punch a ticket on you. Here is a $20 fine. Please pay it out. Okay. So simple. So need to say I want to record it in the event house. So let's go and quickly do an event house. Okay, so I would require an event house. So duplicate. So now this part is done. Transformation is also done. Although I have a very complex notebook for you or very complex event stream for you where you will be writing a lot of complex transformations here, like window based transformations, averaging aggregate transformations on the basis of the windows. So you'll be tracking every vehicle every 5 seconds using the timestamp column, which is a tumbling window operation, and calculate the average of the speed for that vehicle in that timestamp window region, 5 seconds, tumbling window. If that average speed is more than more than 90, it will activate. It will give an activator alert. Again, activator alert. Third time, fine. You have a fine the third time, right? Because first two are mistakes, the third one is a habit, right? So that is something it will catch for you in real time. An event house. So I say I want to keep that output in event house. So I say here I want to keep that in event house. Give your event house a name. So I say vehicle analysis event house. Event house. Event house. Vehicle analysis event house. So here comes a vehicle analysis event house. Here it is, this event house. This event house has one default database inside it, a KQL database. A KQL is a language, Custo query language. It is a data flow expression language, which was invented to process logs, time series data. Log is a time series data, right? So we have over here one database within that. You can see name of the database is same as the name of the event house, because that is default. You can create more databases if you want, right? They will give you one default one. See, at the moment it is empty, has no tables inside it. So now I say output of this I want to now store, then I will report it. Otherwise, if I directly take it to the real-time dashboard, right, if I directly were to take it to the real-time dashboard, that would be wrong. So I can directly take it to the activator to alert. Okay, I don't want to do it, right? I want to first store it in the event house. So I say I want to store it in the event house. Even lake house is an option. You can try it when you practice. So destination name, okay, give it a name. Let's say vehicle event house. Select in which 06 workspace, select your event house, select your KQL database. Is there any table inside it? No, it's empty, no table inside it. So let's create a new table. I say overspeeding vehicles, overspeeding vehicles. These are the vehicles which are overspeeding. Done. Input data is coming in JavaScript object notation format from the original source, which is this body. So I say activate the ingestion after adding the data. I say save. Now it will tell me a preview of the data. So let's test it out. Test result. Refresh. It will show me all the overspeeding vehicles out of the original data. These will be the vehicles who are speeding beyond 90. Right? These are the vehicles which are speeding beyond 90. Right? These are all those vehicles that are speeding beyond 90. This is a real-time data that will pop up. It will tell that whatever the data. So these are all the vehicles that are speeding beyond 90. Some are even going beyond 100. Okay. I could change the logic so that we are getting sufficient results, I think, right? If you want to make it something like 95, then you will find that it will give even less. So these are the people who are essentially breaking the rules, right? These are the VIN, vehicle identification numbers, which are over speeding. According to the GPS data, they are just over speeding on the highway. And I'm collecting it in my. So these are the vehicles. These are the people. This guy is driving in Orlando, Southeast Asia, Southeast region, Orlando, Southeast America, Southwest America. So Chicago, Los Angeles, Orlando. These are essentially done. And this is getting collected over here. Output. We could do way more complex transformations. So if I want to do a very complex transformation, I could go and do very complex transformations like an aggregation. Aggregation on what basis? Aggregate the speed on the basis of the win in a window of 5 minutes. Right? So I have that logic for you. Let's not do that here. It will be a windowed analysis which can maybe confuse people how it's happening. So I'm skipping it because conceptual understanding is first required. Then you can improvise on that. You can add more complex stuff into it. And you can say that for every vehicle that is appearing over here, I want its data to be given to me in real time every 5 minutes to see its speed. So this is it. I say, want to publish this. I want to publish this real time processing engine, right? So now it will connect to the source and then to the, earlier it was in edit mode. We were just looking at a data preview. Now it is connecting. Meanwhile, it is connecting. It will take 2 to 3 to 5 minutes to connect in the real time pipeline to initialize the source and the target, which means it is now running because the source is running, the eventual source you can see. This is my transaction generator application and it is writing or it is sending the data in real time to 94 data, 94 rows every second to the event hubs, to the hubs, right? So you see it is going to this hub. I'm discussing the full pipeline now. So it is going to this hub, as you can see over here. It's going to the hub. Vehicle telemetry is the name of the hub. It is going to this hub. See, it something looks something like this. Okay, going to this hub. We are collecting it via the capture process over here, right? So you'll find for the 16th of February, 2 hours of data, the 14th and the 15th hours, and every 1 minute. So after a few minutes, you will find 45, 47, and so on and so forth. You will find 16th hour of the day. So it is collecting the batch, which we have connected into our lake house. So you will find it in our lake house as well, right? So you'll find it here as well in the lake house that we have placed over here for it. As you can see over here, we have placed for it a shortcut. So all of that data is virtualized over here for us. 20, partition number 0, 2025, Feb, 16th of Feb, hour 14 and hour 15. The data of both the hours is available to us, 16, 14 and 15. And this is the data every 2 minutes it's writing because we configured it over there. Every 2 minutes I want. So this is the batch part. I can now load it to here and then you know what we can do. Okay. But we said, I want to now configure the real time part as well, which is this part, right? So we said we want to create an event stream, then a transformation, then the output goes to the event house in a table, which we can then do a report on. So if you see over here, if I were to go back to the fabric, we have successfully initialized that everything. So if it is working fine, can we now go to the destination where the output of this stream is getting written in real time? So this table is now getting the output in real time. This is the stream. So this is the event house. Let me close all the other things. So this is the event house. And now we will find a table inside it. Refresh. See, it is getting all of this data continuously. It will get. It's not a batch. Nothing is batch here. It's all real time. This is just the output. So here is the table, overspeeding vehicles and the detail of those vehicles, overspeeding vehicles. You can see these are all those vehicles that are overspeeding, right? Their speed is more than 90. So these are all those people who are overspeeding, right? And all of these people, right? So they are continuously getting detected here. overspeeding vehicles. So can I now do any kind of a report on it? Can I say I want to do a report on it? Is it possible to do? Here is an option. Let me take you once to here. So you can directly do a report from here if you wish. But a better option would be to create something called as a real-time report on this. So let me duplicate. Right. So I want to do now some report on it. I want some reporting to happen on this. So let me go to the workspace and I say new item, real time dashboard, real time dashboard, real hyphen time dashboard. Here it is. Give it a name. Let's say real time dashboard, RTD, create. Here is a real time dashboard. You need to connect it to that table, which is this table. Okay. So I say I want to connect it to EventHouse KQL database. Vehicle analysis EventHouse. Connect. And how will I connect? Pass through identity. Add. Which means this person who is signed in. So it has connected now. Right? You'll find it is already connected. If it is successfully done, it is connected. So now what do I want to do? You need to go to this over here. Add tile option. And here we need to write a KQL query to collect the data from the source, right? So we need to now collect the data from the destination table, right? Destination table. I want to collect the data from the destination table. Okay, let me copy a small piece of code here. I don't want, it is not bikes. What is the name of the table here? Overspeeding vehicles. So you need to just take this name here. Overspeeding vehicles, overspeeding vehicles, where ingestion time between now and 30 minutes, last 30 minutes. I can remove this for you if you want, right? I can change it to last 3 minute, last 5 minute window. Summarize ingestion time. This is not needed. Remove this. We don't need this. Okay. Project certain columns. So I only want you to give me just two columns, which is the vehicle identification number and the speed. Okay. And I can even ask you to tell me what else do we have here? City and city. In which city is that person? Right? That's it. Okay. So I will get this thing. Last every 5 minutes, it will tell me timestamp. We can do it, but I'm skipping the timestamp because that's a separate part. Timestamping, window based analysis, right? Okay, that is a separate challenge exercise. Simple query we have to punch. Let's test this out. What output does it produce? It says this thing. These are the vehicles in the last 5 minutes who were overspeeding in a particular city. I say apply the changes, and here are the vehicles that are overspeeding. Okay, I say it that I want not explore, sorry. I say I want to draw a chart. Edit. New title of the real-time dashboard. Overspeeding vehicles. Overspeeding vehicles. And here I say visual type. What type of a visual? I say I want you to have, for me, is there a map? Yes, there is a map. Okay, there is a map. Defined by location. Okay, define the location by the latitude or the geopoint. Geopoint column is the city, and the label column is the city itself. Or let's try the vehicle identification number. Size, show the size on the basis of, yeah, we don't need to show the size. So it will tell us what are the cities where people are overspeeding. Now, if you're counting also over here the vehicles, it will draw a bigger circle for that city. Infer it on the number of count of this, but we are not counting it at the moment in the query, so I'm skipping that. So this is it, right? So what is it going to tell me? What is it going to tell me? It will tell me what are the cities in which you are overspeeding. Okay, refresh. Right, so is it drawing it? It's going over there. Okay, let's say define info. Yes, info. Okay, right, so refresh. Yeah, now it is refreshing. Yeah, now you see these are the cities. These are that which are popping up, right? These are the places which are popping up where it is overspeeding, right? Where it is overspeeding. So if you refresh, overspeeding. I think it's not drawing that. The reason is that it does not have lat long. Let's not do a map. Okay, let's not do a map. Instead of doing a map, we could simply do a stat. Overspeeding vehicles, number of overspeeding vehicles. That's it. A small statistics. We can draw a very complex chart. I will do that demonstration where we will develop a complex chart very shortly. Okay. I can do for you a time chart, right? X column, we don't have a time on this, right? So we could simply go for tip itself. The vehicle identification numbers which are overspeeding on the basis of the city. Apply the changes, and here we have a real-time report. Although I should visualize it, but in the next demo I will visualize it for you. Okay, I have a separate for it. So I say I want to save this report, and that's it. So will this refresh every 1 minute? I can say manual refresh, or I can say auto refresh, enable, refresh interval, continuous, and here also continuous. Okay, I want continuous refresh. Okay, you can write some wrong numbers. So you see it will refresh automatically. See, it is refreshing automatically. It will give me all those overspeeding vehicles. So I am sitting in the motor vehicles observation or some monitoring center. Okay, I'm sitting in the office of the sheriff, and here it is. These are all the vehicles that are over speeding, and here it is, real time, right? These are the vehicles in the last 5 minutes which are over speeding. Orlando, Tampa, and so on and so forth. Just the list of that. In the next demo, I will draw a complex visualization for you. We are doing it, don't worry. Right, here you can see. Real time, last 5 minutes of data, which it tells me that these are the overspeeding vehicles in the last 5 minutes. These are all overspeeding. They're crossing their limit, okay, which is 90 kilometers per hour. They're overspeeding. And you see it is reporting to me in real time what is happening. I can draw a complex visualization, which I will do very shortly from now, within 5 minutes. Did you see the full architecture from here to, so the full architecture is from here to here to the report and also into the fabric delta. Here you have to now decide what batch operations you want to do. What batch operations you want to do, data science, machine learning, data warehousing, that's up to you. Okay. So this is the cold layer, this is the hot layer. So it looks something like this. Hot and the cold. It goes slightly slower because it is cold. So hot, cold. If you tilt it a little bit, it looks something like this. Yes or no? If you tilt this a little bit, it looks something like this. And what is this? What is this? This is the Greek letter. What is this Greek letter called as? This Greek letter is called as lambda.
So that's a wrap for our deep dive into real-time event processing with EventStream, EventHouse, and EventHub. Also, we have got our free Azure job-oriented masterclass coming up, and it's completely free. So check the link in the description below for more details. Also, if you found this video helpful, don't forget to hit that subscribe button and drop any questions in the comments below. Thanks for watching, and be sure to watch our previous video in this series right here.